Hello, everybody, and thank you, Martin, and also your team for making this happen. It's an honor for me to be here with many people and to talk about this subject that's very dear to my heart, which is how to get rid of this technical debt. My name is Brian De Croce. I'm a software engineer based in Montreal. I currently work for the city of Montreal. And in terms of technology, I'm pretty much focused on .NET since the year 2000. But at the city, we do TypeScript, Node, and Mongo development, so open source stuff. So this will cover .NET and also open source, the mean stack technologies. And you can reach me at bdcroce by Twitter, and I'm also on LinkedIn. So if there's any questions, I can also answer. I'll try to look at the YouTube channel, but also on Twitter or LinkedIn would be my pleasure. So for today, we're going to be looking at the context, so the history, the definition of technical debt, and also the side effects when we have technical debt in our projects. Then we're going to look at some solutions through tools and also processes, just in case some of the tools don't apply to us. And then we'll wrap up. Martin, are you ready? Let's do this.
Go for it, man.
Perfect. So I'll let everybody 10 seconds to read this first. The idea of the talk today is maybe to try to be less like the dude on the left with the pointy hairs, and let's try to understand more what is this thing we call technical debt. All right, so let's answer this question. As I was preparing the webinar, the best definition I found was actually on Wikipedia. So the technical debt is actually a concept in programming that reflects the extra development work that arises when code that is easy to implement in the short run is adopted instead of applying the best overall solution. Always a balance between different solutions at a given time. Suppose we have the technical debt in our projects. What is the consequence of it? The best definition I found also for the consequence is the guy himself, Ward Cunningham, who back in the early 90s coined the term technical debt. So in bold, it says right there, his opinion on the consequence of technical debt. The danger occurs when the debt is not repaid. So every minute spent on not quite right code counts as interest on that debt. Entire organizations can be brought to a standstill under the debt load of an unconsulted implementation, right? So technical debt is a metaphor that can be equivalent to the financial debt that we have as a person. And it's all about time versus money to market. It's pretty much what it is. So for example, if you're a startup, contrary to an established brand, well, the decisions that you will make for your projects won't be influenced by the same factors as an established company that has money, time, and lots of manpower to deliver a solution. And depending on the adopted solution, the result can be positive or negative down the road. Now, the negative part is that there will be more work, more time, and more effort to plan in order to get back to the path of success. This is nothing new. This is pretty much the conundrum of project management, right? You want something done with a higher amount of quality. Well, it will take time and it will cost a lot of money. So some companies are actually quite in a good position to do this. But startups, people are building projects on the side for their own businesses. This is a bit hard because sometimes you can only choose two among these factors to guide your project. So it's always about this question. It's about now or later. And it's not an easy question to answer. It's actually super hard. And technical debt will always be present. Its importance, its weight will be determined by the answer to this question. right? So what if you're building a new software that you have to publish to a user base because of competition? What if you're building a mission critical application that could affect people's health, the financial market, or the environment? Now versus later is the question that we have to ask ourselves pretty much every day when we come up with a problem. If we leave the technical side on the side, we can answer the question also by everyday life concerns. For example, I love the right part of the screen, right? Eat delicious, juicy, tasty junk food. And I think I will enjoy it, but I also know that I will pay later with health issues. Or maybe sometimes I should eat boring, monotonous, but nutritious food now, and I'll reap the benefits of a healthy lifestyle in the future. So as you see, technical debt, it's not just about now versus later there. It's also a question of now versus later about everyday decisions in life. Let's come back to technical debt. Why should we not ignore it? Well, let's answer that question by answering a few other real life questions. Take this, for example. If you own a car, why do you wash your car? I mean, I wash my car today and tomorrow there's a possibility it might get dirty again. So why do we spend time doing this? Well, because we're proud of our car. You also want to know early on if there are any defects before you drive it on the road. Think about your software, your code. Pride in our work is important because it motivates us to do good work. So to be proud of our work, there's nothing wrong with that. Suppose we don't own a car, but we have a bike. Why do we wash our bike? Why do we clean it while do we maintain it? Well, it's because you care, because you want to know that your tires, your drivetrain are operational before you hop on and pedal away with it in the streets. Think about your software, your code also in this instance. We don't have a bike, we don't have a car, well, we all have a body. So why do we work out? Why do we stretch? It's because you take care of your body. It's the only thing you have to drive you in life. It's the only vehicle you have to travel and discover the world. The code is the same thing. The code is what will drive your project to get more client, get more money, a little more features, innovate. If we don't do any of this, if we let technical debt catch up to us, then this is what we have in our project. And technical debt can slow you down or shut you down if you're a startup. Pretty much like what Ward Cunningham said in his definition for consequences. And you'll get to your destination, but it will be painful. You'll get there late, and you might get there also in last position. Something interesting I discovered while preparing for this webcast was a little report that Stripe came out with about 2 years ago. And they published the results of a study related to the current state of software development. The report name is the developer coefficient, so you can actually Google this, but I also put the link of the PDF, and the slides will be shared a bit later, so you have access to all of this, by the way. So this is the part of the report that actually caught my eye. So developers spend over 17 hours every week, and we're talking about 40 hours work week, dealing with maintenance issues such as debugging, refactoring, and about a quarter of that time is spent fixing bad code. According to the study, that's nearly $300 billion lost in productivity every year. So they say it's not how many software engineers a company has, it's how their talent is being utilized. If we look into the results more visually, this is pretty much what it gives. We have a 14-hour a week that we work on technical debt and about 4 hours extra on bad code. So in total, we have about 17 hours, which is quite a lot. And technical debt also drives developers mad, angry sometimes. It makes their jobs progressively more difficult, more time consuming, and also less rewarding. So the worst investment that any software developer do when they work on a project, I believe, is themselves. It's their bodies. We're sitting down, our necks are hurting, our shoulders are a bit hunched with the laptop or the keyboard, our fingers might hurt. And it'd be great if we can actually invest our physical being into creating good things that will actually result into positive outcome instead of always reworking or fixing things most of the time. Another study suggests that it costs about $67,000 to recruit and train a new developer in average. So the cost of technical debt adds up quickly when it's chasing developers out the door. So what causes technical debt? Now that we know what it is, the consequences, how can we make sure that we mitigate having technical debt into our projects? Well, there's always complexity. Complexity will always be with us, and that is the main factor that will determine your technical debt in your project. So to understand what complexity is and the different nature of complexity, we should get familiarized with the law of software entropy that states that as the system is modified, its disorder, entropy, tends to increase. So now that we're building more distributed systems, the law of software entropy is so much more important than before, because not only do we have the code base to nurture, but now we have to consider the supporting systems, such as the hardware, the virtual machines, the hard drives, the system memory, the third-party services that we integrate, and more importantly, the networks, such as the internet, where all these components live and communicate with each other. Things can break. In software development, the entropy is represented by the difference or the delta of complexity. We're going to be talking about that in a few seconds. So back in '75, Professor Brooks came out with a book called The Mythical Man Month. In that book, he describes two types of complexity: essential complexity and accidental complexity. As far as I know, he didn't coin those terms. Other people did, but he actually took time to describe it in more in a fashion that more people can understand. Essential complexity is the fundamental required blocks that are put together, assembled to make a system serve and react according to its intended purpose, regardless of the inherent complexity. So without any of this, the system will just not work properly. A good example is a tree. It looks very simple in appearance, but inside of the tree lives quite a complex system that collaborates in a so-called distributed environment. The roots, the leaves, the bark are all affected by its input: water, wind, sunlight. But in return, it produces photosynthesis to output an essential product for life on Earth and under the water, which is oxygen. Most things in nature have an essential complexity. The second and last type of complexity, accidental complexity, is when we temporarily put into our code things are non-essential, maybe to get a short-term gain or maybe to prove something like a proof of concept, but then we forget about it and it remains intrinsic in the system. So when we push it to production, that thing is actually there as well. For the same analogy as the tree, we can think of this. Maybe this place started with just one sign, then another one was put up, then another, and someone forgot to leave the system in a clean state after changing this. Most things made by man have an accidental complexity. So that means that accidental complexity is the main contributor to the technical debt. It's the main, but it's also not the only one. Unfortunately, we also have unrealistic project constraints, right? We live with this every single day, every one of us. A few years ago, I saw this tweet and I kept it because it made me laugh, but it's also because it's quite sadly true. Sometimes also it's just the poor understanding of the problem. We don't ask the right questions, or we assume too much. If we get more technical, it can also be a lack of comprehensive suite of tests, unit tests, integration tests, functional tests with the analysts, or a basic set of customers, for example. We also have an immature design or system architecture. For example, high coupling, low cohesion between components. We could have an incomplete or weak CI/CD strategy. And some of the tools I will present in a few minutes, I'm actually talking about continuous integration as well. I'm going to show you what I use personally in my projects to make sure that I know pretty much the weak points of the system. And sometimes we have also inefficient tools and processes. So this is what I'm going to be sharing about in a few minutes. That being said, software entropy increases in direct proportion to the technical debt. So the more changes we put in our code, well, the more chances that we'll have technical debt as well. But we can manage it using good tools and good processes. Martin, just before I continue talking about the side effects of technical debt, I don't see anything on my screen except my PowerPoint, so I just want to know if everything's okay. All right, by your silence, I guess it is. So the side effects of technical debt. Well, the business logic can be mixed in, intertwined all over the code base. We've seen many times, business logic in our code, business logic in store procedures, business logic shared among components. So that's the easy way to, I guess, advance a project, but at the same time, it's a disastrous outcome waiting for us at the end because it's too much duplication in our code base. Then we also have the consequence of having hundreds or thousands lines of code within a method or store procedure, right? So those are the side effects of having technical debt. If you have to deploy in production many times a day, but just because you're fixing a bug, that's a side effect of technical debt. If you have some security vulnerabilities that are exposed publicly, that's also a side effect of technical debt. Sometimes we also have unit tests that randomly pass or fail depending whether they're executed individually or in parallel. That's also a side effect. And by the way, all this happens sometimes in my projects as well. So I'm not immune to this thing. Let's talk a bit about tools and technologies. What are some things available to us right now, depending on the platform that we use to build software that can help us to mitigate technical debt? I chose this slide, I think because most of us know who this character is, Batman. So this character has no, as far as I know, no superhuman ability other than he's super rich, but he has a belt, a yellow golden belt. And in that belt, there are many tools. And every tool has a specific purpose, and he uses them in the right context to get out of messy situations. So we're going to be looking at a few of those tools in our belts. We're going to look at SonarQube. We're going to look at my IDE of choice that I use for .NET development, which is Writer. If you have ReSharper with Visual Studio, we're going to look at that as well. Then we're going to take some time to look at NDepend, which is my favorite tool I've been using for the past, I don't know, maybe almost 10 years to know exactly what's going on my code. And for those that work with TypeScript or JavaScript using Visual Studio Code, there's a wonderful extension called Step Size that I'd never heard until maybe 2-3 weeks ago. And we've adopted that tool into our projects at the city. And I really enjoy this because it gives us like a super fast results metrics about our code. So we're going to take a look into all of these. So let's show you a bit SonarQube. So the idea is not to present to you the details of the tools. The idea is mostly to showcase what it can do, and from there you can take action by yourself. So I switched my screen to SonarQube. So SonarQube, it's a server that is only good at doing one thing: analyze statically your code, and then output metrics such as bugs, code smells. If you have unit test coverage, it can also display that as well and show duplication. It's open source, so you can use it and put it right now on Docker. There's a Docker image for that as well. So there's nothing that stops you for putting your machine or running a droplet in DigitalOcean or EC2 AWS and set it up immediately. And what it does is once you give it a project that contains source code, and it supports, by the way, over 20 programming languages. So this is one project that's written in .NET. And after it did the analysis, what is cool about this is that you will get a baseline always, depending on your branch. So if I have a develop branch, well, what is the status right now versus the status of the previous commit, for example? Did I improve or did I digress in terms of my quality? So you will have metrics regarding, for example, bugs. And what's really awesome with this application is the user experience. There's almost a tooltip for everything. So for example, a bug, according to SonarQube, is a coding error that will break your code at runtime and needs to be fixed immediately, for example. So if we look at some of this, just for example, I'll take a look at reliability, then we'll come back to security and maintainability. And the way we will use this is, for example, just before you start a sprint, you could devote some time to fix stuff, to make things better in your application. But sometimes you don't know where to begin. You know, where should we concentrate our effort for this sprint? So this kind of tools will guide you, provide you a good answer into where you should look things first. So for example, in this software, if I just concentrate on the language C# instead of HTML, SonarQube is telling me that I'm using a variable that could be null on at least one execution path. And for this, SonarQube said it's a major problem to fix. So if I click on this, for example, I will see that in this C# code, I'm using a variable that it's true. I should have done this differently because in this case, it could be null and it could crash the system at runtime. So that's one way we can know where we should actually invest our effort to fix things. How about vulnerabilities? According to SonarQube, vulnerability is a thing that can be exploited by hackers. So I'm like, okay, let's look at this. And it's mostly about my HTML. And if I look at one of them, it will tell me, for example, in this line of code, you should fix this differently. And if I want to understand why, well, just by clicking the rule, it will tell me the description of the rule. It will also show me an example of non-compliant code, and then the compliant solution based on this, the example of non-compliant, how we can go from worse to good, right? So it's like having, I guess, a real expert close to us, looking at our shoulder, making sure that we're doing the right thing. Then you also have security hotspots. Security hotspots in SonarQube are, for example, based on OWASP, but at the same time, they could be potentially security holes that you should look into it. Okay, so they're just flagged as security holes. It's up to you to decide whether you should do something or not. So what's fantastic also about SonarQube is this view that I want to show you. If, for example, I go back to the bugs and I want to look at one of the C# files, which is this one, I can then look at all the issues in this file, for example, but I can also have a tree map view, which tells me exactly everything that's wrong with this file, not just these things that they have shown. So let me find that for you so you can see it, and then we'll pass on to the next tool. Okay, I'm just gonna select my language, C#. And if I look at my code, and I open, for example, one of these files, and you can get in this through this window from like many other places, so it's all good. I'm just gonna go. Okay, I'm gonna go here, and I'm just picking one C# class randomly. Perfect. You have in SonarQube the measures for the complete code base. So just to give you an example, I just picked a random C# file, and it tells me, for example, that I have this much of cyclomatic complexity. I have how many issues it found, how long it should take me to fix these issues to make sure that it goes to green or like no issues, 0 issues. So using SonarQube is a wonderful tool to know more in terms of metrics about my project at a given time because of the baselines. Something great also that I want to pinpoint with SonarQube is that if you use, for example, continuous integration tool, like I'm using Azure DevOps, but this also works in TeamCity, for example, or Bamboo, or any other CI tools, you can actually integrate it into your pipeline. So I'll show you quickly how I've done that, but then you can also read online how to do this. It's quite simple. So for example, I have a pipeline to build my software. It's .NET. So just before I build the solution, I tell SonarQube, get ready. And then once it builds the solution and run the unit tests and publish the test coverage report, it will run the analysis on that output, and then it will actually publish the results in your SonarQube server. That's how we get this information, for example, with the baseline. And it will tell you on which branch at the same time, master branch, develop branch, etc. Something great with SonarQube, if you're working with an IDE, is instead of seeing these metrics after the build, so instead of having like a reacting to the metrics, you can actually have a proactive approach to this because they have, let me see this, yes. They have a tool called SonarLint. SonarLint is also open source and it's built by the folks that design SonarQube. And SonarLint, what it is, it's an extension that works on all these IDEs. And once you plug it in and you configure it, as soon as you type code in your IDE, you will see the recommendations, the issues, and it's quick. So this is fantastic just before, for example, that you create a pull request or that you push straight to the branch. You will know from the IDE the issues that it will show you. I'm gonna go back. Sorry, there we go. Okay, so think about your continuous integration pipeline where you can actually integrate these tools. The next tool is the IDE that I use to work on .NET projects, which is Writer. And previously, I used to work a lot on Visual Studio with ReSharper. So Writer, if you guys don't know, is pretty much IntelliJ for the Java folks. So with Writer, we have, let me open Writer, which is right here. We have the code inspection tools that work also with the Roslyn compiler, if that makes any sense, like the Roslyn analyzers. So the code inspection is excellent if, for example, you're not using SonarQube, or if you don't want to use it, but you just want to focus on the IDE itself. If you right-click your solution, or if you right-click your projects, you will always have this functionality, this action, which is called inspect code. Just to show you how fast it is, I'll just do it on the solution. So I will say, yes, do inspect the whole solution. And what it's going to do is actually find all the issues based on categories, pretty much like SonarQube. So you will have some suggestions. Suggestions are also divided by categories, which I really enjoy, right? So maybe this sprint, guys, let's focus on quality issues here. So we have 14 issues. Let's try to fix this by the end of the sprint. So if I just expand, it will tell me what the problem is, and will also provide a solution at the same time, which is quite nice, right? So if I double click this and I make this a bit bigger, it's telling me replace enumerable count with the collection count property access instead. So I'm like, oh, okay, it's true, I can do this. Boom, done. So it's quite fast. I don't have a super fast computer at the moment, and the way it does the analysis, it's quite quick. So using your IDE to help you proactively understand where the pain points are, I think that's excellent. So you should use this. And you can take a look at the other issues if you have Writer and you do this. In terms also of Writer, you have the concept pretty much, I guess, like IntelliJ of plugins. So I'm not sure why the mouse is not working, but I'll just continue. There we go, now I can show you. So if you go to your settings and you look at the different plugins, there's a few that are quite nice to have. One of them is called, I have to go back to the PowerPoint just to make sure I have it. Yeah, there we go. It's called CodeStream. So if I go to the marketplace, that's why I couldn't find it earlier. And CodeStream, what it does is allows you to communicate your intent of your code with your colleagues. So this is fantastic also if you're working with remote teams. It's free as well. And it's just a fantastic way to communicate code with other people. Another tool that's pretty good, it's cognitive complexity. So cognitive complexity will display just above the function a metric. So for example, if I have a function here, it will show me just next to my name the metric for the cognitive complexity, which is basically how hard is it to understand your code, in other words, based on some algorithm that someone designed. And it works pretty well, and I think it's the same algorithm that SonarQube uses as well. All right. Just before we go to end append, I'm just going to finish presenting also with ReSharper using Visual Studio. So I opened the same solution that I did in Writer here as well. So a few things that I enjoy a lot about ReSharper is the fact that I just right-click here. If I want to take a look, for example, at the diagram of different components, how they're related, I can actually do this. So if I go to my ReSharper extension and I go to architecture and show project dependency diagram. And ReSharper is quite fast at doing this as well. I guess depending on how many projects we have. So depending on the software architecture that you adopted, maybe you want a certain flow between your components going up or going down. So it's just generating. It shouldn't be too long. I think I see it right here, but it's small. I'm just gonna wait a few seconds and then I will be able to show this. I wasn't able to generate a dependency diagram for my project with Writer. I'm not sure if maybe I missed out something or it's not there, but this is a great tool to use if you need to do this. All right, so where are we here? We're gonna let this run for a bit, but at this, and we'll do something else at this same time. If I look at my solution in Visual Studio, at the same time, I can also calculate code metrics. So this is another way, just like when we do the inspect code in IntelliJ, this is another way we're using Visual Studio to know more about our project or our solution. Many different kind of metrics. So I know this is running, this is building, but it shouldn't be too long. All right. So I have 10 projects in my solution at the moment, and it tells me here more like number-based what they are. Okay. The tool I'm going to show you next, which is ndepend, has all that, but it, instead of showing to you like in a grid, it's going to show it to you visually. So even if we can we see this now? I'm not sure. There we go. Perfect. So I'm just going to make some space. There we go. And get rid of this. Good. So here, for example, we can print this, and then we can have a talk about our project components, how the components, how they are related with each other, to make sure that the architecture, the flow makes sense between each component. Great. Now I'm going to be talking about ndepend also for .NET developers. Here we go. So ndepend, I use it externally to Visual Studio. That's just because on my computer, Visual Studio runs quite slow, so I can't really use it as much. So I will provide, for example, a solution or assemblies, and it will take care of crunching things. Now, I know there's a lot of things being shown here at the moment, but I'll just show you the basic ones that I use for now, and from there, you can take it a step further. So, for example, I just asked ndepend this morning to analyze the same project that I provided to SonarQube and IntelliJ and Visual Studio, and it will give me, for example, many things. I have how many rules were broken, and these are software engineering rules as well, and I'll show you a few of them. You have the debt that's been calculated, a rating, how much time it's going to cost me to actually fix this debt, to make sure it goes to 0 or almost to 0. In terms of dependencies between assemblies, I can see this visually. And what's really awesome with ndepend, again, is always the UX that I enjoy in tools. And the UX talks to me, tells me, what is this information that I'm looking at the moment, right? What's the relationship between this assembly with this other assembly? So visually, you can see this quickly. So it's great for that. At the same time, if we're more visual people, we can look at the dependency graph, and the dependency graph will tell me, for example, that I have an assembly called domain entities, and it's used by 2 other components, but in green, as you can see below. And at the same time, this assembly is using how many other components in blue. In this case, there's 4 other components that it's using. So with this, I can know, for example, if I have too much complexity in the way my components are assembled, which can slow down the application at runtime, but it can also provide, can open the door for issues down the road. In terms of metrics, this is a tree map view. It shows me, for example, if I look at the cyclomatic complexity of the overall solution, where are the pain points? in terms, and I can see the size, for example, in terms of line of code, number of methods in a given type, etc. So if for example, your application, your code is suffering from different factors, well, you can actually pinpoint each one of them to have a better understanding. So this is great for that, and I can choose another view as well. For example, I want to know, I don't know, I don't have code coverage for this, but in lines of codes, for example, how much lines of code? So show me the places in my application where there's way too much code, which means also that maybe I should have more tests for this, right? One thing also with end-depend is, remember how I told you to take a look to consider your continuous integration pipeline. It integrates fantastically with so many other tools. Jenkins, if you're a JetBrains user, maybe you want to use TeamCity for your continuous integration. Well, it does that just fine with the TeamCity plugin. In my case, I use Azure DevOps, and I'll show you what it looks like. I just have to find it. It's here. Perfect. So if I run, for example, a pipeline to build a code base or a change for my software, I will have an end-depend window here. And there I will see, oops, sorry about that. I clicked the wrong place. There we go. So it will take a few seconds just to generate the report so that if I don't want to look or use Visual Studio or the Visual end-depend external tool, I still have all that rich information about the current state of my software in my pipeline, in my continuous integration tool, I should say. Okay, so the screen is a bit small, but you can see, for example, the issues with the debt that it calculated. So pretty much like SonarQube, but a bit more visual, right? So I have, for example, a function here. It's telling me the debt will be 15 minutes to fix it, and it tells me what's wrong with it. And sometimes it will also provide a quick solution. This is how you should fix it, not just what's wrong with it. Then you can look also at metrics if you want to take more decisions that are based on metrics like numbers instead of just emotions, right? Like, I wrote this code, so I know it's good, there's no bug, I'm not gonna fix it. Well, this might tell me otherwise. So to have all this at hand quickly is what allows us to make, I think, good decisions down the road. The last tool that I'm going to show you, and this is pretty much last minute, it's if you're using TypeScript or JavaScript and also making use of Visual Studio Code, which more and more I'm using at my place of work. This tool, let me put just the name so I don't forget. This tool is called Step Size, and you can Google this, and I'll show you what it does. Oops. And it's super quick. Once I open a workspace or a folder containing my code, within a few seconds, for each JavaScript or TypeScript function, it will calculate a debt, right? So I just opened a new, I got this from GitHub last night just to change projects. And I opened one file called model, and there's a few functions here, and some are decorated with a mark, right? So there's one thing called month to day. I don't know exactly what it does, and it's good, right? Easy to understand, unlikely to be buggy. Nice job, for example. But if I look at something that has less than an A, like a C, and I'm just going to make more space. So this is function get population params. It's a C. The length is quite too much, right? So it will tell you maybe what's wrong with it, and also provide some solutions at the same time. right? So we'll tell you that the length it's red, so it's like, oh, it's a bit too long for what it should be. I think it has to do also with the parameters. It has way too many parameters. Oh, argument count, there we go. So the argument count makes that makes it a C, for example, at the same time. Okay, so this you can quickly know where your pain point is in your code. And they're working on something really good that I'm enjoying this tool is you can link to tech debt issues if you have a GitHub account. Basically, if you're working in teams in the same code base, you can share comments about this code base with other people in your team. So that it's not just with using Slack or Hangout chat, everything can be related. So comments and code, which is just fantastic. So we have the tools, right? And there are so many others, but those are the top ones that I use in my day-to-day life, I guess, for my personal projects, but also at work with my clients. Let's look into the practices of extreme programming, and we're not going to be talking about XP. Actually, it's just the practices, right? So these are some things that you can do as a team if we let go of the tools for a minute of how you can decrease technical debt in your apps. Pair programming helps a lot. You know, if you pair with someone that knows more about the business or knows more about the technology or knows a few more, I guess, best practices, that can help to have a proactive approach in creating code that is pretty much defect-free. If you can have the whole team physically together, that's great. At the moment, everyone in my team is working remotely, so communication is key. Look into your continuous integration pipeline. I think it's the third time I'm saying this, but it's because it's so important. See if you can integrate these kind of tools in yours. Refactoring, take time to do that. If you don't know what to refactor, use the tools that will tell you where you should invest your time. You know, have some coding standards as well so that not everybody is doing whatever they think is best for the project. At work, we use TS-lint, a linter for TypeScript, to make sure that the coding respects the guidelines that the team, I guess, adopted. You know, have collective code ownership. That's super important so that you're proud of your work and everyone, if the ship sinks, you know, everyone sinks, but if the ship gets to destination, everyone wins. Favor simplicity in your design as much as possible, right? This is, I guess, the Yakni you aren't going to need it approach. No need to be fancy, just make it work, make it right. And sustainable pace. Try to look also into the values of extreme programming. Again, let's not care much about XP, but let's look at the values. So the communication is one of them. Not only communicate with the good communication amongst your team members, but the communications with the users of the system, right? The goal is to give all developers a shared view of the system, which matches the view held by the users of the system. So to have a clear path of communication is important. Favor simplicity as much as possible. That's going to be really the key to make sure that either you get rid of technical debt, but that you actually don't increase technical debt. Right? So the simple solution should win. Feedback. The feedback is not from just your users telling you how good the system is, but have unit tests that tell you how the system is behaving at any given time. Yes, have feedback from the customer. You know, those that do also acceptance tests. It's important. Feedback from the team. You know, when customers come up with new requirements, the team directly gives an estimation of the time that will take to implement. So there's also discussion there. So like poker planning, I think they call it in Scrum. So the feedback is super important. Have also the courage to change things. You know, if something needs to be refactored because down the road there's going to be a bad outcome if we don't, have the courage to do this. Have the courage to try new tools, to try to change things if the status quo is that we actually have technical debt every single day. Think about that Stripe report that we just talked about half an hour ago. There also the respect, right? It's one of the values of XP. So it's not just the respect for your fellow team members, but the respect for your code, the system. I tell my team members, we never code for ourselves. We're always coding for the next person who will take our seat, who will take position into our code at some point. And we have to think about that person, because I think most of us at the same time, at some point in our career, we're actually going to work on other projects. And it's great if we can work on a project that is, the foundation is pretty solid and there's no much cracks, right? And Martin, I'm about to wrap up. So we mostly talk about today technical debt. We saw the context of technical debt. We saw the consequences when we have that in our projects. We saw the side effects of technical debt. We look at some tools and also some processes that we can put into effect. And the only slide that I've prepared for this to conclude is this one. You don't have to ask permission to do the right thing, right? Like, to spin off SonarQube is just a Docker machine container. You just run this on a machine on your laptop if you must, and then you can show it to your team. You can show it to your management, what it can do. It's actually what we've done at the CD of Montreal. We integrated one project in SonarQube, then another, then there's 40, and now we presented this to the architecture committee, and they've adopted it. So now in our Jenkins build system, we're going to be using SonarQube, so that if we push change that, let's say SonarQube gives us a B or a C, well, it will break the build for that pull request, for example, or that commit. So I'm going to leave it at that for now. Martin, I'm going to give you back the thing. We have about, I think, 5 minutes left.
Yeah, perfect. Thanks. So there's not a lot of questions right now. There is one great remark that I think very much fits into the closing slide that you had there. And that's always code as if the person who ends up maintaining your code will be a violent psychopath who knows where you live.
I love it.
All right.
Yes, why not?
On that bombshell, I think we can switch back to my screen. All right, with that, for the people who are still here, thanks everyone for joining. Again, thank you, Brian, for presenting this very interesting webinar. I have a couple of links on the screen here. If you want to learn more about ReSharper or Rider, do check our websites. We're also on Twitter. We don't only share product information there, but also general tips and hints on practices and so on. So if you're interested, follow us on Twitter. The recording of this presentation will be available on YouTube, on JetBrains TV, but we'll also post it onto our blog, and we'll make sure to include the resources to Brian's presentation and a couple of the tools that he covered in this demo. And of course, if you feel like chatting with Brian or there's anything else you want to discuss, do follow him on Twitter and reach out if you have any feedback on the presentation and so on. With that, thanks again, and keep an eye on our YouTube channel. Thanks, everyone.